All right, today we're going to be learning about how to complete the square. So we're going to start off by looking at a couple equations that we can solve by taking the square root. So if we wanted to solve x squared minus 16, we would undo this x squared to the squared by square rooting both sides. And x would equal, what two numbers can we square to get 16? We can square 4, or we could also square negative 4 and get 16. So we need to say x equals positive or negative 4. Similarly, we have this whole quantity squared, so we can square root to undo that square. We'd get x minus 2 equals plus or minus. We can't simplify the square root of 5, so we're going to leave it as the square root of 5. And then we need to get x by itself by adding 2. Since square root of 5 and 2 are not like terms, we're going to leave it as x equals 2 plus or minus the square root of 5. But what about x squared plus 4x minus 5? We can't just square root because we can't square root one term, and if we square root this, we're going to end up with a square root of x, which is not helpful. So what we need to find is called a perfect square trinomial, and it looks something like this: x squared plus 3x plus 9. The reason this is a perfect square trinomial is because when we factored it, what two numbers multiply to give you 9 that add up to 6? It would be x plus 3 and x plus 3, which we can rewrite as x plus 3 squared. This helps us out because then it looks similar to the problem we had in our second example up here. So if we have x squared plus something x, we can add something else on to find our c value to turn it into a perfect square trinomial. That c value is going to be equal to b divided by 2 squared. So here our b was 6, half of 6 is 3, 3 squared is 9. Then we can plug it in. If we have x squared plus bx plus this c value, we know it'll factor to x plus b over 2 squared. Just like here, this factored, half of 6 is 3, it factored to x plus 3 squared. So let's practice that a little bit. If we have x squared plus 8 plus something, we're going to take our b value, which is positive 8, divide it by 2, and square it. 8 divided by 2 is 4. 4 squared is 16. What would that factor to? What two numbers multiply to 16 and add up to 8? It would be x plus 4 squared. For this example, our b value is negative 7. So we'd have negative 7 over 2 squared. Negative 7 divided by 2 doesn't simplify, so we just square each number, which will give us 49 over 4. And we're always going to use fractions, never decimals. Then we'll have x, and then the number inside our parentheses is b divided by 2. So negative 7 divided by 2 would be minus 7 halves squared. This is going to be the major process to completing our square, because we complete the squares by putting this number on the end, so we can rewrite it as a quantity squared. So our steps to solving a quadratic by complete the square. The first thing we need to do is get the x's on the left and the constants on the right. So if we're looking at this example, our x squared and our x terms are already on the left, so they're going to stay there, and we don't have any x's on the right, so our x's are fine. We need to move our constant of 4 to the other side to be with the other constant of 25. So we're going to subtract 4 from both sides, and we'll have x squared minus 8x equals 21. Then we add b over 2 squared to both sides. In order to keep our equation nice and balanced, we have to add it to both sides. We can't just add it to one. So x squared minus 8x plus something equals 21 plus something. So in this example, our b is negative 8. So we'll have negative 8 divided by 2 squared. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. Then we're going to factor the left side and simplify the right side. We can rewrite x squared minus 8x plus 16 as x minus 4 squared, and that'll be equal to 37. And then finally, we're going to square root and solve. I'm going to rewrite the problem real quick. So we're going to square root both sides. Square and square root undo each other. So we'll have x minus 4 equals plus or minus the square root of 37. If we could simplify the square root of 37, we would. So we're just going to make a note. Simplify the radical whenever possible. And we reviewed simplifying square roots a little bit in our complex numbers lesson. If you need some help with that, make sure you're coming to see me or going to Math Lab. All right, so let's look at two more examples which have some special situations. Let's say we have something like this. 2x squared minus 12x plus 26 equals 0. So the main thing that's different this time is that we have a number in front of x squared, meaning that our a is not equal to 1. So what if a does not equal 1? To solve this problem, to fix getting rid of that 2, we divide all terms by a. Every single one. So this one, this one, this one, and even the 0 on the other side. So we'd be left with x squared minus 6x plus 13 equals 0. Now that it's alone, we can follow the steps on the front. We want the x's on one side, so on the left, so these stay. Move our constant to the other side. I'm going to go ahead and leave room to add our b squared over 2 for our next step. Step 2, add b over 2 squared to both sides. Negative 6 divided by 2 is negative 3. Squared would be 9. Factor this, we'd have x minus 3 squared equals, simplify this side, we get negative 4. Next step, square root and solve. So square root, we'll have x minus 3 equals, remember every time we square root, we're going to have plus or minus. Negative 4 is negative 1 and 4, and we're square rooting each of those. Square root of 4 is 2. Square root of negative 1 is I. And then finally add 3 to the other side. Are 3 and 2i like terms? Hopefully you said no, which means we can't add them together, so we'll leave it as 3 plus or minus 2I. And for our last example, everyone's favorite, yay, we have fractions. So what's our first step going to be since we have a number in front of x squared? The first thing we're going to do is divide all our terms by 2. We get x squared minus 5x plus 2 equals 4. Step 2, get the x's on one side, the numbers on the other. Leave space for our b over 2 squared term. B is negative 5 divided by 2, and we square it. And that'll give us 25 over 4. This side will factor to x minus 5 over 2 squared. Your fractions you can add on your calculator. Let me pull mine up to show you. So we have 2 plus 25 over 4. 2 plus, the nicest way to get the flat fractions is alpha y equals, enter, 25 over 4. And by doing it that way, when you push enter, it automatically puts it in a fraction for you. So we'll have equals 33 over 4. Then we need to square root both sides. We'll have x minus 5 over 2 equals plus or minus. The key to square rooting fractions is to square root the top, so the square root of 33, because we can't simplify it, over, and make sure your radical is completely on the top of your fraction. The square root of 4 is 2. So then we'll have x equals, I'm going to add 5 halves to both sides. Since the square root of 33 has a square root and this fraction doesn't, they're not like terms, we can't add them together. So we'll have 5 halves plus or minus the square root of 33 over 2. And that's it.